Hello. So we are back Thursday, and I'm back to work from Monday, but only hard jobs, very busy. Yeah. So let's fix a TV. We didn't fix a TV from a long time. So we have a nice TV here, Meos TV. Uh, what model is Meos or Meos? It's 13.3 inch. It's a TV DC 1224. This is quite hard to burn this TV because it's 1224. Yeah, this is dead. I don't know what killed this TV. Was booked in yesterday for no power. Yeah, no power. How do we test this kind of TV? We have a port. The power port, this one, for AC adapters only. What?
The iPhone X is the ear speaker flex.
Yeah.
Ear speaker flex.
That's the moment you realize you are such a dump. So I did test the TV with my power supply, but just now, when I read for AC, the power supply is DC. So probably this TV is good. No, wait. What do you mean AC? For AC adapters only. How this is possible to be for AC when you have input DC 1224? This TV is confusing. So this is AC or DC? Because on the for AC adapters only. Okay, the adapter should be AC. Yeah, okay. Yeah, I got it now. It's confusing. Anyway, how do we check something like that? Power supply, 12 volts, 13, 14. It's not important. You can go for 14 because when the car it's off, you have 12 volts, probably on the battery 12.4. When the car is on, you'll have around 4.1, 4.2 volts on the battery, which is perfectly normal. Obviously, if it's 12, if it's 14, or even 15, they will be fine and still work fine. So how do we check a TV, like a 12 volts TV? So we need a ground. We have here a USB and a HDMI port, so we can use the metal bit, which is ground. Yeah. And okay. Yeah, it's not staying there. So that's ground. Yeah, on my case I use the metal from the USB and plus here on the middle. And on the middle is getting nothing. Anyway, I will keep this here and I'll press the power button, which is here. And it's doing nothing. The problem is it's taking no current. Nothing. Something is clicking. I don't know if it's a mechanical click or whatever is here. But it's taking no power. So probably it's some mechanical thing because it's taking no power. There's no way like to be a relay there. So we have a dead TV. and we have to fix it. So let's see, how do we open this? We have some screws here. But it is confusing for AC adapter. Okay, so does my adapter has to be AC? No, it must be DC. It's a DC adapter. It's confusing. If you think your adapter should be connected to the AC, yeah, it's perfectly logical. But I never seen this kind of, AC adapter only. Does that mean the TV is taking AC? No, it's taking DC. Or maybe it has different input for the car battery. I have no idea. Maybe. Oh wait, yeah, it is has. For car cable only. So if this TV is burned, was burned by this connector. Probably they switch the plus or minus. Okay. So how we can open this? More screws. What about these screws? Now it seems logical. This is for AC adapter and that one is for the car cable. So it's getting open. So what we expect? We expect something to be blow up there because when you do things like play on the with the power. Okay, this is the so this has a regulator, yeah. So you see, yeah, this is a nice TV. I admit it, but that's because the TV is 1224. So you see, this is these are the wires from the port, the input port, the voltage, and it's going on a regulator, which probably is regulating. Like if you connect 24 on the output of this one, it will be still 12. So that means it's quite hard to burn this one. Here we have the other port. Okay, I'm just curious to see what can be wrong here. Because it's hard to burn this board if you play with the voltage here, like do something wrong. So you can burn this, the regulator, but should be working on this one, or it's not. Okay. Okay, let me take this out. Yeah. Let me take this out. And we have a fuse here. Here we have a fuse. Here we have a fuse. Let's check the fuses. The fuse is burned. Diode mode. This fuse is gone. And this one, this fuse is good. Possible, like the customer is using this TV on on his home and not on the car. So he didn't use this. He didn't use this connector from here. Okay, so what I will do. This is kind of stupid, you know. Just use the regulator for the both ports. So you connect this port with the other port on a parallel mode, and everything goes on the regulator. On that case, probably the man even now has a working TV. But just because of the energy saving thing, they didn't connect this port to the regulator. They connect the port straight to the board. Okay. Let's see, minus. Plus after the fuse. So we have the fuse. So we test here, nothing happened here. What about on the other side? On the other side it's taking 400 milliamps, which probably the TV start. It's on already. And it's going to 0, which is perfectly normal. So now the TV is on standby. It's taking 10 milliamps. You can see on the power supply 10 milliamps. And that's normal. That's the standby current. The TV is waiting for you to press the power button. Okay. Okay, this was an easy one. All what we need a proper calibrated fuse here. Yeah, and this TV will be working again. I'm kind of disappointed, you know, it's nothing blow up, just a fuse. It's a nice TV. Nice one, yeah. Let's yeah, I was thinking, you know, if the fuse is gone, probably something it's, you know, it's more faults are there. Well, it's not. It's just the fuse, and we have the standby current, which is normal. It's kind of funny. I don't have the adapter, so we have to test this with the power supply. Okay, the fuse. So here should be around 2 amps. But I still ask myself how this get burned. Probably he used a wrong adapter. Probably he used a laptop adapter. Yeah, that can be possible. So let's connect these buttons, because we cannot press the power button. Give me 1 second. 1 second. So let's try again. 14 volts. But how can I do it in a way so you can see exactly what's going on here? Plus, okay, let's turn it on the other side. Minus, plus on the middle. It's taking 400 milliamps. Should go to 0. Yeah, it's going to 10 milliamps. Pressing the power button. It's not 10 milliamps, like it's 100 milliamps. Pressing the power button. And it's working. So it's going up to 900 milliamps. Probably with sound and everything will go like 1.5, not more. So we are fine. Yeah, this was an easy one. The logic part is working. Okay. Yeah, I know. This is a boring one. Yeah. Give me 1 second. Yeah. Let me find something else. I'll find something else. Yeah. Of course, I'll replace the fuse with the original one. Anyway, I'll stop this video. I know it's disappointing. I was thinking it's more because the people, this stuff on 12 volts on the battery, they blow up. Like anything, like audio amplifiers, TVs, whatever it is. They are doing like mistakes connecting like 24 volts instead of 12, twisting the plus and minus, and yeah, it's anyway. See you on the next one. I'll take a break. I'll take my lunch break because it's 1 o'clock, and after that, hopefully we can find something more interesting. Yeah. Bye.